Here's a quick tutorial on naming esters. To form an ester, you need an organic alcohol and carboxylic acid. They crash into each other, those molecules, and form an ester and water. It's important to look at how this process occurs in order to more easily see how to name the ester. So we'll do an example. Let's take the alcohol ethanol and the carboxylic acid propanoic acid. I'll draw the structural and condensed formulas for each. For ethanol, F is a 2-carbon alcohol. And the functional group is OH, the hydroxy group. For propanoic acid, the functional group is COOH. I'm going to draw that close to the oxygen, which you'll see why I'm doing so in a minute. And propanoic acid is a 3-carbon organic molecule. That's prop. Each carbon has 4 covalent bonds, either as single, double, or triple. In this case, the rest of the molecule is all single bonds. Here are the condensed formulas: CH3, CH2, OH. And for the acid, CH3, CH2, COOH. When you add those together, you get an ester and water. So let's see how this ester forms. Both molecules have very polar regions where the electrons are unequally shared between oxygens and hydrogens. So I'm going to put in red here the oxygen on the alcohol, and in blue by the hydrogen on the acid. When those molecules crash into each other in that orientation, the proton from the hydrogen atom is transferred to the oxygen on the alcohol, and that's where water is going to be formed. At the same time, the electrons between the carbon and oxygen break off of the alcohol and go onto the oxygen. So there you have your water molecule. And now I'll put this region in green. The electrons that stayed with the oxygen in the propanoic acid, they are going to transfer to the carbon that just lost 2 electrons to the oxygen that formed water. So basically water is going to form, and the rest of the acid is going to combine with the rest of the alcohol. And I will draw that down here so that I have room here. So the ester that forms comes from the alcohol, which no longer has the hydroxyl group. So there's CHHH, CH2, and then I'll draw in green the oxygen that came from the acid, and the rest of the acid molecule. That oxygen is still bonded to a carbon that's double bonded to another oxygen. That CO group is known as a carbonyl group by itself. And then CH2, CH3. And this oxygen that formed the bond to the carbon still has 2 pair of electrons, as did the oxygen and the carbonyl. I'll just throw this in. Okay. So here's the ester that forms. And of course, The H, originally from the acid, is now part of the water molecule, H2O. So there's your ester and water. So this is how any ester forms. It's the alcohol losing the hydroxy group and the acid losing the proton, or the H plus ion, to form the water and the ester. Now to name this product, just look at the name of the alcohol that was used or consumed in the reaction. Ethanol. And we're just going to use kind of the first part of the name and put a YL suffix there, ethyl. And from the acid, which is propanoic acid, we just use the propano part, so everything except the ic, and that becomes the last part of the name of the ester. It changes to O8, so it's propanoate. So that is the name of that particular ester. You may not see the full structural formula of the ester and need a quicker way to write that using the condensed formula. So in this case, the condensed formula would look like CH3, CH2, and then starting with the acid, we have OOC, and then CH2CH3. However, more typically, you'll see the acid part written first in the condensed structural formula, because that OOC looks a little bit disturbing. So starting with the acid, the right side, we have CH3, CH2, COO. Then I'll write the alcohol part in a different color. CH2, CH3. So that is the typical way that the condensed structural formula will be drawn, but what you have to see is that there's a dividing line between the carbon that has both oxygens bonded to it, and you could tell that that cannot possibly be this carbon, even though that there are two O's to the left of it. This carbon already has two H's bound to it, so to have another double bond to an O and a single bond to another O and then a bond to a C is just far too many negative electrons around that C, so that could never happen. Nevertheless, once you draw that dividing line, after you find the COO group, you'll know to start the name, there's a 2-carbon part of the chain. That must have come from the alcohol. There's the ethyl part, and then here's the acid part. So count the carbons, 1, 2, 3. So that's the propanoic part. Once you get the hang of this, drawing out the mechanism, then you could just do kind of a rapid-fire drill on naming or predicting the names of esters as follows. Just line up the alcohol and the organic acid, and then you can quickly get the ester name. So for example, if the alcohol is methanol and the organic acid is ethanoic acid, the ester is going to be called methyl ethanoate. Now what will this look like? Here I'll draw the structural formula. Methyl CH3. So that used to have an OH attached to it, but that went over to form water. And from the ethanoate part, there's the oxygen from the acid that has to be bound to a carbon that's bound to another oxygen, double bond. And ethanoate has a total of 2 carbons, or ethanoic acid does. So then just draw one more carbon. And in a condensed way, starting with the acid, we have CH3, COO, CH3, methyl ethanoate. Let's say the alcohol is 1-propanol. You need the 1 to indicate that the OH group is at the end of the carbon chain. There is such a thing as 2-propanol. And let's say our organic acid is butanoic acid, a 4-carbon organic acid. Therefore, our ester will be called 1-propyl butanoate. And here I'll just write the condensed structural formula. From the butanoate, you'll have CH3, CH2, CH2, COO. The 4th carbon in butanoate is part of the acid group. And then the 1-propanol will be CH2, the OH broke off with that final carbon, and then CH2, CH3. Esters are known for their fragrant smells, usually pleasant, like pineapple, coconut, apple, peach, etc., etc. Ironically here, butanoic acid smells pretty bad. It's one of the acid components of throw up, vomit, that makes it smell pretty bad. But when you react that with propanol, you could change that into an ester that smells pretty good. All right, so that's how to name esters.